Hello, welcome to Solving Systems of Equations by Substitution, Lesson 5.2. You've already learned how to solve systems of equations by graphing. And graphing is wonderful, but not always the easiest way to do it. So today we'll talk about a new method, substitution, one that you can use whenever graphing isn't the one you want to use. Later on we'll learn a couple more methods that you can use when you don't want to substitute or graph. So the idea here is to learn a lot of different ways so you have options. But this is the second option, substitution. Solving systems of equations by substitution are quite simple. You already have them on your paper. Let's go through them real quick. We start off, we look for a variable that's by itself, or something that has a coefficient of 1. You look at the three examples I give you. The first one we have y equals 2x plus 3. The y is by itself. The second one I have x equals 3 plus 7y. And again, the x is by itself. And the third one, we don't have a variable that's technically by itself, but we do have one with a coefficient of 1. We have 2x plus y equals 5. That is by itself. Now, what we can do to make substitution work is we can rewrite this one real simply. It's not quite as much as setting up to solve, but just take that 2x and put it on the other side, where this becomes y equals negative 2x plus 5. And now we have y equals. Okay? Our next step is to substitute into the other equation. Then we'll solve for the lone variable, the variable that's remaining after we substitute. We'll take that solution and substitute back into the original equation. That way we can solve for the second variable. And then we'll write our solution as ordered paired, but you already know that. And we will then check our answers. We always want to check because it makes it a lot easier and we'll know exactly if we get it right or wrong. So we'll start with example 1, where we have y equals 5x plus 2 and x plus 2y equals 48. So our first step is to look for that variable that's all by itself, and here we have the y. Now we see here that the y is equal to 5x plus 2. These two things are equivalent, so what that means is we can replace them. They're interchangeable. So we're going to look down to this one. Here we have the y. We're going to take that and plug it in there. Now watch what happens when we do that. We get x plus 2 times 5x plus 2 equals 48. No big deal, except that now we have only one variable. We have x, we have it twice, but there's only one variable. We know how to solve for that. So let's go ahead and finish this. Let's go ahead and solve for x. It's going to give us x plus 10x plus 4 equals 48. We can simplify that now. It becomes 11x plus 4 equals 48. We subtract the 4 and we get 11x equals 44. Divide by 11 and we get x equals 4. So now we know that x is equal to 4. And we got one of our variables. Now remember, our variables are eventually be written as an ordered pair. So let's go ahead and put the 4 in there. Now we're going to take this and we're going to plug it back into the one of the original equations. Now, I'm going to go with this first one here. I'll explain why in just a second. But I'm going to replace the x, because we know x is equal to 4. And I'll have y equals 5 times 4 plus 2. No variables. I can just simplify this out and get y equals 20 plus 2, which is y equals 22. Now, as you can see how easy that was, I chose this first equation because I could just plug it right in and just calculate it. If I had chosen to replace this x with 4, I would have still gotten 22, but I would have had 4 plus 2y, had subtracted 4, divide by 2, do a lot of extra work. You get to choose which one you plug it into. I always try to plug it into the easiest for me to solve. So anyway, I get y equals 22, and that is my... So now that we know our solution should be 422, let's check it. Checking's real easy. In fact, after a while you just do a quick check in your head. But let's take each of our equations and let's plug it in. We have y equals 5x plus 2, so that would become 22 equals 5 times 4 plus 2. 5 times 4 is 20. 20 plus 2 is 22. So 22 equals 22. That's correct. I could have checked it with the second one as well. 4 plus 2 times 22 equals 48. 2 times 22 is 44. So 4 plus 44 equals 48. And that is also correct. So double check. We got it right. For our second example, let's try this one. We have x equals 3y minus 9 And 4x plus 5y equals 2. Again, as we look around, we see that we have an x by itself. This is going to work out exactly like the one before, except now we know that x is equal to 3y plus 9, so we're going to plug that in for the x. Now when we do that, we're going to get 4 times 3y minus 9 plus 5y equals negative 2. And now, one variable, we start simplifying. That's 12y minus 36 plus 5y equals negative 2. We can combine those and get 17y minus 36. We're going to add the 36, giving us 17y equals 34. Divide by 17, and we get y equals 2. So again, I'll put my, well, it won't be like that, will it? Put a 2 there, put the comma there. Take that, plug it in, and again, we can plug it in either way. Again, like the last time, I'm going to take it into the top. So I have x equals 3 times 2 minus 9. So that's x equals 6 minus 9, which is negative 3. So y is equal to, x is equal to negative 3. Now, notice as I stumble through there, mixing my x and y's up, this is why we check. And so we'll check that here in just a second. But that's why we check, because it's very easy to just plug into the wrong thing, or to calculate incorrectly, or to just write it down incorrectly. So you always want to take a second to double check it. Okay, so now let's check it. We got our solution of negative 3, 2. So let's plug it in. I'm going to start off with the top one again. That's going to give me negative 3 equals 3 times 2 minus 9. So negative 3 equals 6 minus 9. And that means negative 3 equals negative 3. That looks good. Just to double check, checking in the bottom one. That's going to be 4 times negative 3 plus 5 times 2 equals negative 2. That's negative 12 plus 10 equals negative 2. And so that's negative 2 equals negative 2, which is correct. So now we know that we do have it correct. Usually just checking in one is good enough, but we always want to double check if we can take a second to do that. Now for example 3, we take a look at this. We have x minus y equals 2. So we have two variables sorted by themselves. We have x and we have a negative y. For the second one, we have x plus 6y equals negative 19. Now, neither one of these do we have a variable all by itself, but we could change either one of them into an equation that we could use. The top one we could change into x equals y plus 2 by taking the negative y and flipping over to the right. For the bottom one, we could take that and make it x equals negative 6y minus 19. So we have choices. I personally stay away from negatives, so I'm going to go up to the top and change this one to x equals y plus 2. All I've done is take this negative y and added it to both sides. So now I have x equals y plus 2, which I'm going to then plug in right there. This one's also kind of easy because when I plug it in for x, I'm going to have y plus 2. There's no distributing that need to go on. Plus 6y equals negative 19. Okay, so that's 7y plus 2 equals negative 19. Subtract the 2, and I get 7y equals negative 21. Divide by 7, and y equals negative 3. Let's go up here. Negative 3 there. All right, next, I'm going to take my negative 3 and I'm going to plug it in either one, and it really doesn't matter which one here. If I go to the top, I have x minus negative 3. I kind of want to stay away from that. I'm going to plug it into the bottom. So I have x plus 6 times negative 3 equals negative 19. That's going to give me x plus negative 18, or x minus 18, equals negative 19. So I'm going to add the 18, which gives me x equals negative 1. So now I know that that is negative 1. And then we could probably check. And now that we know the solution is negative 1, negative 3, let's go ahead and check it. Might as well just put it right in the first one. We're going to have negative 1 minus negative 3 equals 2. Negative 1 minus negative 3 becomes negative 1 plus 3, which is 2. So 2 equals 2. That's correct. Let's double check the bottom one. That's negative 1 plus 6 times negative 3 equals negative 19. That's negative 1 plus negative 18 equals negative 19, and that is true because negative 19 equals negative 19. So we've done all three. We've solved our systems. We've got it in an ordered pair. We've checked them all. We've done a good job. So finally, let's talk about the steps we followed. Remember, this is one method. It's not the only method to solve equations or solve systems. We graph to your state. Sometimes graphing is great, sometimes it's not. But if we want to use this, what we do, we look for a variable that's by itself. Look for a loner. Once we find it, we substitute and solve into the other equation. We find one of the variables. We then plug it back in, find the solution. For the second variable, we write that as an ordered pair, and we go ahead and check it. And that brings us to the end, where I will remind you to come up with your question of the day. A lot of new things going on. If you have any questions, have any problems, make sure you're asking and getting those taken care of so you understand what to do.